Alright, so in this video we're going to learn how to use the reduction formula. This will be, I'll have four different examples. The difference in the different examples is the alpha. It'll be in different quadrants in each video. I'll have a video where alpha's in the first quadrant, another one that's in the second, then another one third, another one fourth. So you can check them all out. So what we're doing is we have sine x plus cosine x, and we have a coefficient for each one here. And what we're going to do is we're going to rewrite it as a single sine function. Instead of having two trig functions added together, it's just going to be a single one. So if alpha is an angle in standard position whose terminal side contains AB, then a sine x plus b cosine x is equal to, and this is going to be the square root of a squared plus b squared times sine of x plus alpha for any real number x. So we know how to get this number here in front of sine. X is just going to be x, and then we've got to figure out how to find alpha. Now, depending on what textbook you're using, or how your teacher tells you to do it, there's different ways to find alpha. There's also, you've got sine alpha is equal to b over the square root of a squared plus b squared, and you've got cosine alpha is equal to a over a squared plus b squared. Okay, you can use either one to find alpha. I just always like to use tangent alpha as b over a. And look, all this is, look, if you have an angle here, and it doesn't matter what quadrant it's in, and say it contains, the terminal side contains the point AB, so we know this is A, this is B, okay? And look, this side here is the square root of a squared plus b squared. See, Pythagorean Theorem. And if this is theta, I mean, look, that's where these come from. Okay, so if we call this a squared plus b squared, if we call that, say, r equals that, okay, you probably recognize this. Okay, we can say r equals a squared plus b squared. That's the hypotenuse of this right triangle. Here's your angle. This is the side opposite, and this is the side adjacent. So we know that what tangent alpha is what opposite over adjacent, b over a. Look at this. The sine, well, I know I'm using theta here, but it's the same thing. Theta alpha, doesn't matter which angle you use. But look at this. The sine of the angle, what's sine? Opposite over hypotenuse. You see that? Opposite over hypotenuse. And look at cosine. The cosine of this angle is adjacent over hypotenuse. So that's all that is. Okay, so whichever your teacher tells you to use, just use whichever one. Okay, but like I said, in these videos I'll just use tangent alpha equals b over a. That, to me, that's the easiest one to do. And plus a and b are given to you, so you don't have there's not a chance of, in case you make a mistake calculating this, then your angle will be wrong also. So just use what's given to you there. Okay, all right, so let's go ahead and get started on the example. All right, so let's look at example 4. We want to use the reduction formula to rewrite negative sine x plus square root of 3 cosine x in this form, a sine x plus c. Well, if you remember in the formula, this right here, the directions just put an a here, but that a represents that a squared plus b squared. That's all that is. Instead of writing this, they just used an a there. And then your angle here, c, if you remember in the formula, that was alpha. Okay, and they just use different letters, and depending on what book you use, they might use different than what I'm using here in the video. Okay, the important thing is to be able to find all that stuff. All right, so let's go ahead and convert this into this form. So the first thing we need to know is what little a and little b are. So I can see that a is equal to, that's the coefficient of sine, so that's -1. B, that's the coefficient of cosine, that's square root of 3. Okay, and so now we can get a here. So a, or big A, is equal to the square root of -1 squared plus square root of 3 squared, which that's the square root of 1 plus 3, which that's 4. Square root of 4 is 2. Okay, so there's big A. Now let's look for C. All right, so to find C, we can use tangent of C is b over a. b over a. So that's square root of 3 over -1, which gives me tangent C is negative square root of 3. All right. So we need to take the inverse tangent to get our angle. But notice we have a negative here. Okay. So we're going to have to find the reference angle here. So what we need to do first is see which quadrant our angle's in. So we could actually come up here and we can plot the AB, okay, because remember it says the terminal side is AB. So if that's -1 and then positive square root of 3, so our point's going to be up here somewhere in the second quadrant. Well, not theta, C. And so what we'll do is we'll need to find our reference angle, C prime. I just use a prime. Some books use different symbols, okay, whatever your book uses. All right, so to find our reference angle, well, we're going to say the tangent of C prime is equal to, now remember, the sine, cosine, or tangent of a reference angle is always the positive value. Okay, it's always positive because remember, reference angles are all in the first quadrant. So my reference angle, well, what would this be? That's what? 60 degrees. And so this is 60 degrees. And so now I can get C is equal to what? 180 minus 60, which is 120 degrees. So there's C. Now, well, we've got C and we've got big A, so we can just plug it into here. But let's suppose we did this in radians, okay? So if we did this in radians, then our reference angle would be what? Pi over 3. And so that would give us C is equal to what? Pi minus pi over 3, which would be 2 pi over 3. Okay, so this is if you would do it in degrees, and this is if you was to do it in radians. And so now we can say that negative sine x plus square root of 3 cosine x is equal to, and that's going to be the big A, which is 2, and that's going to be sine of x plus, and I'll write it in degrees. And then let's just come down here and we'll rewrite this where we have the radians. So 2 sine x plus 2 pi over 3. So either one, whichever one your teacher wants. If they want the angle in degrees, this one. If they want it in radians, this one. Okay, so check out the other videos. Give me a like, share, and subscribe. And thanks for watching.